So now with completing the square, we have actually two ways of solving quadratics. The first way is to factor, second way to complete the square. However, we found limitations in both actually. If something doesn't factor, we can't find out the x-intercepts. We can find out any x-intercept if we complete the square, but completing the square tends to be a little painful when we get that b term that's odd. So there's one more way in which we can take and solve a quadratic, and that's using something called the quadratic formula. And this, much like completing the square, will solve any quadratic, no matter what, whether it factors or not. And we remember, once again, quadratics come in the form of ax squared plus bx plus c is equal to 0. And the quadratic formula states this, that the value of x is equal to the opposite of b plus or minus b squared minus 4 times a times c all over 2a. So the first thing we'd have to do in a situation like this is make sure the quadratic is equal to 0. Therefore, I have 3x squared minus x minus 12 is equal to 0. Then we identify the a, b, and c terms. A is equal to 3, b is equal to negative 1, c is equal to negative 12. And then we plug that into the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So let's go ahead and do this. The opposite of b is a positive 1 plus or minus the square root of 1 squared minus 4 times 3 times negative 12. And all that is over 2 times 3. So we have 1 plus or minus the square root of 1 plus whatever 48 times 3 is. It's going to be 144 over 6. So that's 1 plus or minus square root of 145 over 6. This is the exact value. Then we can approximate this value by plugging into a calculator. So this would actually give 1 plus or minus, by round, that's 12.04 over 6, which is 1 plus 12.04 over 6 and 1 minus 12.04 over 6. And again, those would equal roughly about let's go 2.17 and negative 1.84. That's the approximate values. Once again, exact values, no decimal, in simplified radical form. So let's do another one. This is already set equal to 0. Identify a, b, and c. A is equal to 2. B is equal to negative 2. C is equal to negative 5. And then I have the opposite of b, so that's 2 plus or minus the square root of negative 2 squared minus 4 times 2 times negative 5 over 2 times 2 gives me 2 plus or minus square root of 4 plus 40 all over 4. I have 2 plus or minus the square root of 44 over 4. This is going to simplify a little more because we have a 4 and 11 here, so this is 2 plus or minus root 4 times 11 over 4. Bring this over here. It's 2 plus or minus 2 root 11 over 4. Notice I have a GCF on top of a 2. I'll factor that out. That's 1 plus or minus root 11. It's over 4. Therefore, the 2 and the 4 reduce, and I have 1 plus or minus root 11 over 2, and that's the exact value. Again, I could put that into a calculator to get an approximate value, but I'm going to leave it in an exact form. Let's do it again. A in this case equals 1, B in this case equals 1, C in this case is 10. So now I have the opposite of B plus or minus 1 squared minus 4 times A, which is 1, times C, which is 10, over 2 times 1. Now you'll notice in this case we end up with a negative square root. What this tells us is that since no number multiplied by itself is a negative number, there is no solution. So most likely, if we were to graph this parabola, it would look something like this. No x-intercepts. Now, with that in mind, we have something called the discriminant, and the discriminant is actually the value of the expression underneath the radical sign in the quadratic. So the discriminant, let's call it D, is equal to b squared minus 4ac. Now if the discriminant is less than 0, which means it's negative, a negative under a square root would mean there are no x-intercepts. That's like the problem we just did, or no solution, and our graph would look something like this. If the discriminant, whatever was under the radical sign, was actually equal to 0, then what that would tell us is that we would have one x-intercept or one solution, and our graph would be something like this. If our discriminant is greater than 0, we say we have two x-intercepts or two solutions, and then our graph looks something like this, or two x-intercepts. So when we're asked to actually state the value of the discriminant and determine the number of solutions, we first of all have to get our quadratic in a form set equal to 0, and then identify our terms. A is equal to 3, B is equal to 10, and C is equal to negative 12. And then look at our discriminant of b squared minus 4ac. So in this case, that's 10 squared minus 4 times 3 times negative 12, which gives us 100 plus 144, which is 244. Clearly that's greater than 0. Therefore, there are two solutions. What those solutions are, we don't know, but the problem didn't ask us to find the solutions. It just asked us to state how many we had. So now we're going to apply our quadratic formula to an application problem. And what's happening here is this town wants to build a treatment plant that's 70 on a piece of land that's 75 this length by 200, which is this length. And we want the buildings to total 10,000 in area, so this rectangle in the middle is 10,000, and we want to allow as much space around the buildings as possible. And notice I have equal space in this figure drawn. So what I know is I know that if I want the dimensions of this rectangular piece of building, I'd have to take from 200 x in this direction and x in this direction. So that's 200 minus 2x. That would be this length here. And then if I wanted this dimension, that would be 75, and take x from here and x from here. So this is 75 minus 2x. And the product of those two would be a length times a width, which would give me an area of 10,000. So notice what I can do is I can FOIL from here. 200 times 75 gives me 15,000. 200 times negative 2 is negative 400. X minus 150. X plus 4x squared is equal to 10,000. Now this is a quadratic once again, so I'm going to need to set aside equal to 0. I get 4x squared minus 550x plus 5,000 is equal to 0. And in order to find x, I would either have to factor this, or I could use a quadratic formula where 4 is my a, b is 550, and c is 5,000. And again, these are pretty big numbers to go ahead and factor. They're also going to be big numbers for the quadratic, but I can plug this into a calculator, which I'll probably do. So if we take the opposite of b, I have 550 plus or minus the square root of negative 550 squared minus 4 times 4 times 5,000 over 2 times 4. So this is 550 plus or minus the square root of 222,500 over 8. So now I can take and find x by just popping this into a calculator, and that gives me a value of 121.46 and 9.79. Now only one of these makes any sense, and the only one that's going to make sense is a 9.75, that being because if x was equal to 121.46, two x's would be bigger than my 75, and thus wouldn't have enough space to put the two buildings. So x is just equal to 9.79. So again, we've seen some applications for using the quadratic formula and found that we can use the quadratic formula for basically any type of quadratic we want to solve for x with. Also, we found that the discriminant helps us determine the number of solutions but doesn't exactly find a solution. So write your lesson summary up and answer the questions below, and we'll talk more tomorrow.